Welcome to video lesson 10.4 on using the Pythagorean theorem. So what we want to do today is we're going to use the converse of the Pythagorean theorem and the distance formula. Okay. Now, a converse of a statement just switches the hypothesis, the if part, with the conclusion, the then part. Okay, so as an example, if we have the statement if P then Q, the converse is if Q then P. So remember the Pythagorean theorem said that if we have a right triangle, then it will be true that a squared plus b squared equals c squared. Okay. Now the converse says if the equation a squared plus b squared equals c squared is true for the side lengths of a triangle, then the triangle is a right triangle. So for part of our question today, we're going to be given the three side lengths. Okay, and we're going to have to determine based on those three side lengths, is that indeed a right triangle? Do the three side lengths fit in that a squared plus b squared equals c squared? Is that equation true? Remember, the biggest thing to remember is that c is always our hypotenuse, which always has to be the longest side. Okay, so of the three values they give you, doesn't matter what you substitute a or b, c has to be the longest of the three sides. Okay, we'll do an example. So for A, we have a triangle of side lengths 7, 24, and 25. The 25 is the hypotenuse, so we have to see, is 24 squared plus 7 squared equal to 25 squared? If it is, then yes, that is indeed a right triangle. If it is not, then no, it's not a right triangle. So 24 squared is 576, 7 squared is 49, 25 squared is 625. When we add 576 and 49, we also get 625. Since 625 equals 625, yes, this is a right triangle. Okay. So is it a right triangle? Yes. If those would not have been equal, then no. And remember again, the way we determine what the hypotenuse is whatever the longest side is. Okay. So in this case, 40 squared plus 80 squared, does that equal 90 squared? Okay, so 40 squared is 1600 plus 80 squared is 6400. And does that equal 8100? Okay, and that 1600 plus 6400 is only 8,000, okay, which is not equal to 8100. No, not a right triangle. All right. Now we have some more information for you. We can use the distance formula, which is derived from the Pythagorean theorem, in order to find the distance between any two points that are in a coordinate plane. Okay? So the distance formula is right here, and I'm going to rewrite it. This is kind of sloppy because I wrote it on, or just copied it from the website, so it's a little blurry, but the distance d, okay, equals the square root of the difference of the x coordinates squared plus the difference of the y coordinates squared. Okay? And they're showing you sort of what that looks like. So if you have 2 points, okay, we have the point x1, y1 here, and we have the point x2, y2 here. Okay? This is just forming our right triangle between those 2 points. So how we would find the Pythagorean theorem, from here to here squared, plus here to here squared, and then the square root of that would be our distance. That's what this is showing. Okay? So it's just simplifying the Pythagorean theorem down, using it to find the distance between 2 points on a coordinate plane. Right? Now we want to use that formula to actually find the distance between these 2 points. Right? So we're going to let x1, y1 be that first set. So x1 is -3, y1 is 3, and x2, y2, the board's a little off, sorry, is going to be 2 and -1. Now, the distance formula, okay, is the square root of the difference of the x's squared plus the difference of the y's squared. Okay? So now we have the distance equals the square root of 2 minus negative 3 squared plus negative 1 minus 5 squared. Okay? This will be 5 squared plus negative 6 squared, which is 25, plus 36. So we want the square root of, 61. It doesn't come out to a perfect number, so we're just going to keep the distance as the square root of 61.
After this period, at approximately 11:20, when your teacher dismisses you for lunch.
Now, example 3 says a football coach designs a passing play in which a receiver runs down the field, makes a 90-degree turn, and runs to the corner of the end zone. A receiver runs the play as shown. We want to know if the receiver actually did the receiver run the play as it was designed. So did he really make a 90-degree turn? Okay. Each of those units is 10 feet. Okay. So distance 1, is going to be found by distance 1. So we have our x2 60 minus 20 squared plus 50 minus 10 squared. Excuse me. Okay, and that'll be 40 squared plus 40 squared. Okay, and that equals the square root of 3,200. Okay, which will be feet. Distance 2. Okay, we have the square root of, now our x2 is going to be 80. 80 minus 20 squared plus negative 30 minus 10 squared. Okay, so that'll be 60 squared plus negative 40 squared, okay, which will end up being the square root of 5,200. Distance 3, the final one, okay, will be 80 minus 60 squared, again it's the square root of all this, plus negative 30 minus 50, sorry about that, squared. Okay, so we have 20 squared plus negative 80 squared. All right, and that's going to give us a total of the square root of 6,800 feet. Now, those are our 3 side lengths finally. Okay, 1, 2, and 3. We can see that 3 is the largest. Looks like, according to this, it should be the hypotenuse anyway. Now what we need to do is use the Pythagorean converse, okay, to see if this indeed is a right triangle. So we have the square root of 3,200 squared plus the square root of 5,200 squared, and that should equal the square root of 6,800 squared. Okay, square root of 3,200 squared is just 3,200 plus 5,200, and that should equal 6,800 if that is indeed a right angle here, which is where we're trying to see if they made that 90-degree turn. Okay, now the sum of 3,200 and 5,200 is 8,400, which is not equal 6,800. So no, the player did not run the play as designed. All right. If you have questions, this is kind of the longest problem. Please make sure you ask. Okay, I'll be happy to go over them in class. Now you have a couple practice problems utilizing the converse of the Pythagorean theorem in 1 and 2, the distance formula in 3 and 4, and the distance formula again and the Pythagorean theorem in number 5. So we're changing and we're saying that the receiver made the turn at 30-20 instead of 20-10. Okay, so you're still starting at 60-50, still ending at 80-30. Okay. Please make sure you answer the questions and have a great day. Thank you.